G'day, Josh Flyger, top bloke. So let's make a start. Year 12, we're looking at the sine rule today. Sine rule's interesting. It has stuff to do with trigonometry with non-right angle triangles. That's a bit of a newbie. Never seen this before. Good stuff. So what we're going to do, we need to, with the sine rule, we talk about sides and angles. Angle A here is opposite side A. Angle B, which we're going to pick another colour, is opposite side B. And last but not least is our old friend C. Angle C, side C. Always opposite each other. Where we go? There we go. Sine rule. So, here's the sine rule. You're given it in two different ways. Either way, you can use it. It's on your formula sheet, so it's very important. To find a side, put the side on top. Find an angle, you put sine A on top. It's used to find. Used when you're given those two things, two angles and a side, or two sides and an angle. Either way will work. Now, when we're using it, we actually don't have two equal signs next to each other. It's just there so that you know that you can use it with C's if you've got a C. Next slide, wrong way. Right, two formula, two different results. One's good for finding a side, one's good for finding an angle, and to change it to the other one, we just flip everything up the other way. It's included on your formula sheet, as I said. Wrong way again. Right, here's an example. We need to find a side. We got this one is opposite this one. We got this one opposite this one. Wow. So, check that they're opposite each other. If they weren't, we could work out this side working out using angle sum of a triangle. Remember, all triangles, the internal angles add to 180 degrees. Whew. Right, here's my formula. I plugged in what I knew. So the B's were 4.1 and sine 37. And I had sine 50. Multiply by sine 50 to get x all by itself. Plug it in your calculator, round to the required number of decimal places. 2468, Bob's your uncle, don't wait. Now, in this case, however, we're going to find an angle. So that means we're going to use the other one. So here's our picture. Draw a big diagram. So 4.5. From the base of a 3 metre sloping wall, angle of elevation to the top is 36 degrees. So, here's the base. There's our 4.5. And we got a sloping wall of 3 metres. Presumably that it connects up in a triangle, and we've got our angle here of 36 degrees. Once we got that, we draw our pretty picture. That one looks a lot better than mine. And we want to find the angle at the top. So again, check that your sides are opposite your angles, write out the rule. This time we put the angle on top because we want to find an angle. Plug in our values. We're going to move that 4.5 by timesing by 4.5. Nothing amazing, nothing new, just playing around with a new formula. There we go. And it asked for, I should have written sine -1 of theta equals that. And then we do sine of the -1 to work out the answer. And as always, if you get all the questions wrong, check your calculators in degrees mode. Have a good day, Year 12.